Okay, so let's start your full mock for your interview preparation. And I think you're preparing for Travancore Titanium Limited.
Yes, yes.
When you are having your interview, and the interview you are having through some kind of campus placement or outside campus you are looking for some opportunities.
Sir, it is an Kerala state government company. So I wrote the exam and cleared that. Tomorrow is my interview.
Tomorrow you are having interview. Fine. Okay, so let's start your interview. Down before that, please introduce yourself briefly to us.
Okay, as you said, my name is Don David. I'm from Pavarti. It's a small village near to Guruvayur in Thrissur district of Kerala. Then up to 12th, I studied in nearby school. Later, I went for a diploma in mechanical engineering from Sri Rama Government Polytechnic College, Tripura. During my diploma studies, I took part in NCC and I was a senior there. Then my diploma project was four-way power hexo. Then later I went for B.Tech in mechanical engineering from RIT Kottayam. And during my B.Tech studies, I took part in many student organizations like ISTE and SA India. Participated many events conducted by this organization. Then my B.Tech project was experimental investigation and parameter optimization of TIG welded 15 CDV6 steel. That's all about me.
In which year you have completed your BTech? Don.
2019.
2000. So what you are doing from last 2 3 years?
Sir, I was preparing for GATE and other competitive exam.
So you appeared in GATE this year also.
Yes.
So how much is your score?
602.
602.
Uh,
Okay. And what score you got last year?
Before that, 500 something, 527, I think. I remember.
So in 1 year, there is no such significant change is there in your GATE score.
Sir, actually, first time my rank was about 10,000, but this time it's about 2,600. Yeah, there is no significant change in mark because exam was very tough this time, but
Mhm.
there is a significant change in rank, all India rank.
So this year you are having rank close to 2500 all India rank.
2,600.
Mm, okay. So you worked on some project related to TIG welding parameter optimization. So what are the critical parameter actually you have considered for optimizing TIG welding?
There were four parameters. One was the welding speed, then wire feed rate, then second was the uh, inert gas flow rate. Yeah, these three parameters we used in that.
Why these three only? From where you got the idea?
Sir, actually, the welding, sir, sorry, one more parameter is there, the welding current. Four
Mhm.
parameters. So the welding current mainly influences the uh, welding, the quality of weld. Then we took three more options for doing the. Actually, we used the Taguchi method for optimization purpose. So
Mhm.
in that we require some parameters and levels of each parameters. So that's why
No, why these four only? Like the four parameter which you have chosen, why these four?
these four parameters mainly influences the quality of weld.
So can you tell me the influence of these parameters? Like what kind of effect you are going to get if you are changing the current, if you are changing the welding speed? One by one, can you
Sir,
tell us some brief about this?
sir, actually, we used ANOVA for get to know about which parameter influences more.
Mhm.
So by using ANOVA, we came to know that current influences more than 90% current has the highest influence. Then remaining three parameters has very less influence.
So tell us the important conclusion of that study.
Sir, actually, the output of Taguchi method is an S by N ratio, signal to noise
Mhm.
ratio.
Mhm.
So the aim of experiment was to get optimized parameters. So the quantities with the highest S by N ratio was our output, and we conducted
But I think
actually.
those things are already there, na? Like in the literature also, if you will check. People already conducted
Sir,
similar kind of researches. So what new work you carried out in that?
sir, we adopted TIG welding for joining of 15 CDV6. Before that, only arcing and laser welding was there.
Are you sure about that?
Yeah, I hope so. See, yeah, and our electrode was some different one, stainless steel. So there was no literature for like these parameters
Stainless
with
steel
the
electrode
stainless
you have
steel.
used. Stainless steel electrode.
No, not, I mean filler rod.
Filler rod stainless steel.
Yes,
And what is the base material?
basically it was in steel alloy.
Alloy steel. So welding of alloy steel you used TIG welding.
Yes,
Can you tell us the thickness of that plate you welded?
sir, I don't remember exactly.
So what do you think? That is not a parameter. Like if you're optimizing all those things like the current, the speed, without taking the thickness, you can optimize all those things. What do you think?
Uh, Sir, actually, for a given thickness, we are considering other factors.
Yes,
Of
that's
course,
why
the
I'm
thickness.
asking. What thickness you have chosen for that experimentation?
Sir, I don't remember the exact value. It was about 9 mm or yeah.
अच्छा heat affected zone क्या होता है? What is heat affected zone? And if you
Sir,
will compare with this TIG and MIG, what do you feel? In which case heat affected zone is highest? High, much bigger. What is heat affected zone?
heat affected zone means it's a region, it's a portion of a base material which got affected due to the fusion of base material while welding happening. So by in a fusion welding, a portion of base metal melts and joins together, and adjacent to the melting portion, there will be an heat affected zone. And comparing TIG and MIG, uh, I think MIG has a very less heat affected zone.
Why?
Sir, actually, in a TIG we use as DC state polarity. More heat generates at the base material. But in case of MIG, the wire we use is an consumable one. More heat generates at the electrode itself, not at the base material.
Acha, what is quenching? What do you understand by quenching?
Yes, quenching is an heat treatment process, mainly intended to increase the hardness of the material. So we are suddenly cooling the material with the help of a cooling medium like water from the melting point directly to the
So
temperature of
how hardness of a material increases when we carry out the quenching?
the micro martensite structure forms while quenching occurs. Martensite is a very high, hard, and brittle microstructure.
Hmm. Okay. So have you explored the website, Don? You're aware about the product developed by this company?
Yes.
So you're going for Travancore Titanium Product Limited.
Yes.
So can you tell us something about this company?
Sir, it is located in the Trivandrum district of Kerala at Kochueli, and started in the year 1946 with the
Mhm.
collaboration of British Titan Products Limited.
Mhm.
Then, with the vision of Travancore Maharaja of that time, Sri Chitra Tirunal Balaramavarma Maharaja. Then,
Mhm.
1951 started production with a capacity of 5 tons per day. Then it further increased to 10 tons per day in 1960 and further to 18 tons per day in 1963. The company taken over by the Kerala government by the year 1960. Later, it started production of sulfuric acid also. In 1996, um, the company started to produce sulfuric acid with all the latest safety regulations, safety equipments. The major products include titanium TiO2 of retail grade and acetate acetate grade. Then other products include potassium titanate and sulfuric acid.
So is there any reserve available in India related to this titanium?
Sir, what?
Where we can find titanium reserves in India? And what are the main competitor of this company, Travancore Titanium Products Limited?
Actually, Travancore Titanium Products is the largest manufacturer of TiO2 in our India. It's a leading manufacturer of our country, and the raw material for TiO2 is ilmenite, which is largely found on the banks of Kollam beach. So it's near to Kollam beach.
What are your favorite subject?
Strength of material, thermodynamics.
Okay, tell us one more.
Then production.
Okay, so you like strength of material, thermal production. Okay. Okay. So at last, again, I will discuss with you. Don't. So now Atinder sir is going to discuss with you. Yes, over to you, sir.
Thank you, sir. So, Don, I have my first question about the company only. So, the product they are making, so where do we use that product? Like titanium oxide, dioxide, where do we use that?
Sir, TiO2 mainly used in cosmetics and also to make sun cream. Then TiO2 is known as the whitest of all, so it is used in paint pigments. Then used in paper industry, then plastic industry, etc.
Okay, so the company basically do the refining of the. It will have some basic part, and it will extract some of its constituents and take out TiO2 from it. What is that process called? Like
Sulfate process.
what process?
Sulfate process.
So, are there any chemical reaction happening, or there are some other physical methods they are undergoing? How they do it?
Sir, from ilmenite we are extracting the TiO2. So some chemical reaction happening there. The reaction is known as the sulfate reaction, and the ilmenite is a combination of TiO2 and iron. So it is first treated with sulfuric acid to form. So first it's treated with the sulfuric acid. Then the byproducts are hydrated to get TiO2.
Okay, so do you know anything about chemical reactions? How they are classified? Homogeneous, heterogeneous, order of reaction. Do you have any idea about that?
No, sir. No, sir.
Okay. So, anything how we calculate at what rate that reaction will take place? So, if I have a reaction A and B are merging together and forming C. So, do you know anything about rate of the reaction? How will I calculate?
Sir, that's I don't know. We can use catalyst to accelerate the rate of reaction. That's only I know.
Okay, sure. So, let's go towards your favorite subjects, and I will ask some question from thermodynamics. Okay,
Okay.
is it fine?
Okay, sir.
Okay, so if I talk about any thermodynamic process, like I will choose one, I will say isentropic process. Okay, it is
Sir,
one.
I didn't get, sir, not clear.
I have choosing a thermodynamic process. Let's say isentropic process.
Okay.
So tell me, in reality, do isentropic process happen or not?
Uh,
Are they real or imaginary or ideal? Whatever you say.
Sir, isentropic process means the entropy change is zero, and I mean, in our case, entropy change is zero. So this can be happen in real life also, because if the system has some entropy generation means the entropy is added, entropy increases. Plus, if the system loses some heat, so minus of entropy. So altogether, we have a change in entropy as a zero.
Okay. So what about isothermal?
The
Can they happen?
yeah, it can be happen.
Give an example of isothermal process. How will
Uh,
it happen? How will you practically have a isothermal process? Any isothermal process?
Sir, in a Carnot engine, there is an isothermal process. Here, when expansion,
Carnot is ideal.
yes, yes.
I am talking about real life.
Um,
Can you achieve isothermal process in real life or not? And if you can, how will you achieve it? Tell me the process. If I want to achieve a compression, suppose isothermal compression, can I achieve it?
in real life, it is not achievable.
Not achievable.
Not achievable.
Why?
Why? Because, for example, in case of compression, when compression occurs, the temperature increases automatically. So we have to remove the temperature. I mean, remove the heat from that. Then only the temperature will remain constant. So for a
Okay.
compressor, the process occurs very fast. So both together we cannot manage.
So there is no process in the whole world where isothermal condition can persist. Do you agree with this statement or not?
Yes, sir. I am agreeing with that statement.
Okay. What about other isobaric, isochoric?
Sir, isobaric and isochoric process means pressure constant and volume constant. That
Yeah.
can happen in real life.
That.
Can happen in real life.
Okay. Give me an example of isochoric process. An example in real life which you have seen around you. It should be isochoric.
Uh, Sir, I'm not able to
Okay.
recognize.
Okay. So we have four processes: isentropic, isobaric, isochoric, isothermal. We read all these four. You are saying three of them are happening in real life, but one of them is not happening in real life.
Yes,
Then why are we studying it?
sir. Actually, the isothermal process has the highest efficiency for a process. I'm speaking about a process. So we want to achieve that, but it is
Okay.
not possible.
Can you prove that isothermal process has highest efficiency? How will you prove it?
Sir, we have a first law of thermodynamics for a process as Q is equal to U plus W. So for a process, since the change in internal energy will be zero because it's an isothermal process, no change in temperature. So all the heat we are given completely converted into work itself. So it's a 100% efficient process.
Okay. And what about others?
Others are not 100% efficiency. In real life, we want to achieve isothermal process. It's not possible actually.
Okay. 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 So let's go to little deep into it. Suppose I have one process, say a piston cylinder arrangement, and I am pushing that piston cylinder, and this is I'm assuming it to be isentropic process. Okay, fine. I'm pushing it, and it is I'm doing it. In real condition it will be isentropic because it will have some heat loss to the surrounding, and because I'm pushing its temperature will also rise a little bit. Okay, fine. Now in the second case, I have another piston cylinder arrangement, but in this case, I am doing it in a isothermal way, ideally, which according to you is ideal condition. So in which case, work done will be more by me. I'm pushing isentropically, I am pushing isothermally, in which case I will have to do more work. Tell me.
In isentropic case, we have to work more because we require work for two cases. One is for compressing the gas, and secondly to overcome the friction. So in isentropic case, work required will be more.
And what about in isothermal? We don't have to work against the volume, and friction is also there. Why it is different from isothermal case? Which of these two is not present in isothermal case?
Sir, you are saying about a reversible case.
Whatever you like, you give any assumption, take any assumption, and tell me in which case we will have to do more work and how.
Sir,
How will you decide it?
okay, sir. If both case I am taking it as a reversible. So in case
Okay.
of isothermal, there won't be any friction directly. The work directly given for compression.
What is this friction? Tell me how you define friction. What is this friction?
Friction means happening between mating parts. So it happens due to the irregularities on the mating surfaces. So
I am letting friction for both the cases. Okay.
okay.
So now tell me, in which case work done will be more?
Sir, on the PV graph, the area under the isentropic case is more because it has more slope.
Okay, then okay. So can you tell me why it is more? Why the the area under the PV curve for the isentropic curve is more? Can you physically relate to it? What is happening inside the cylinder physically?
Uh, Sir, in
So
isothermal case, there is no rise in internal energy, but in case of isentropic process, we have to give work for compressing plus to increase the internal energy. So
okay,
isentropic case work will be more, and the slope is very steep compared to isothermal case. That's why more area below that.
okay. So I will give my review now. Okay.
Okay.
First is my first thing is that you should read about little bit about chemical reaction also, because your company is related to chemical reactions only. Okay, they are doing chemical transformations. Okay, they you can find a good book or any like small lecture on chemical reactions, how to classify them, how to find the rate of equation. Okay, so all these, just get an overview about it because they might ask about it. Okay.
Okay.
Second is all the four processes are can happen in real life. Okay, isentropic, isobaric, isochoric, isothermal. So I will start with the example of isochoric, which is present in your home also. Your mother cooks in a pressure cooker, so that pressure cooker is an example of isochoric process. Okay, when a piston cylinder arrangement, and if it is very fast, as in the case of our this bikes and every automotive vehicles, so the piston is very fast, the process is too fast. Okay, so in that case it can be considered as adiabatic, but there is heat loss because there are fins and everything, so heat is getting lost, so an isentropic process take place over there.
Okay.
Okay, now this isothermal and isobaric, both these process will be very slow processes. They will not be very fast because you have to wait for the heat to be rejected to maintain at the same temperature. Okay, and again, in the case of isobaric process, you have to reduce the temperature to get a lower pressure, to get the same pressure for the lower volume.
Okay.
Okay, so in that case, you have to even go little more slower to compress the same amount of gas at constant pressure. Okay, these are the few examples of constant pressure. Now, constant pressure and constant everything is real. Okay, you can achieve them in reality, but practically we don't use them. We use only isochoric and isentropic most of the time. There are some processes like boiling. Now, boiling happens at constant temperature. This is a process of ison, is, isothermal. Okay, so boiling is happening at is isothermal process. Then there are many other processes, like if a chemical reaction is taking place and it is exothermic or endothermic, depending on what kind of reaction it is, and if you are able to maintain the same temperature in that for that area, because most of the time it happens that you are supplying heat and that reaction needs that heat to take place, and there is no rise in temperature, so you get a again isothermal process. So there are many examples of isothermal process in the nature also. Okay.
Okay.
So okay. So my last was what happens in to the work done by a person who is compressing isothermally and isentropically. So your answer was right at the end that isentropic process will be more, but why? You know that internal energy is increasing. Now temperature is related to pressure. You know,
Okay.
temperature is if you have a particular temperature, it will affect to pressure. How? Now you need to understand. If I will increase the temperature, the molecule speed will increase. The molecule's velocity will increase. You know, velocity is a function of temperature. The kinetic energy of a molecule is a function of temperature. And because of this relation, the particle speed will increase inside the domain if temperature is
Okay.
increasing. So because of that increase in velocity, it is hitting the wall more. So therefore, the pressure is increasing. So it will be very difficult. It will be comparatively difficult to press a highly agile particle as compared to a very calm particle.
Okay. Okay.
Okay, these are the two differences you need to understand. Okay,
Yes, okay. Okay.
all the best, Don. Give
Okay,
your
thank you.
best in the interview.
Okay.
Okay.
Okay. Yes. Hello, Don. Don, when you are going for some company dealing in some kind of materials, so you'll to have some kind of awareness about the extraction technique.
Okay.
Raw material. What is the main raw material for this titanium? अब इंडिया में कौन सा मिलता है? You know, there are different forms of that raw material available. But इंडिया में कौन सा available होता है? And कहाँ पे मिलता है? You need to have some basic information about that. And after that, how we extract. There are some specific extraction techniques. And I hope easily you can get these kind of information if you will explore.
Okay.
Extraction के लिए क्या करते हैं? Like titanium oxide है, you are getting the titanium oxide as a raw material, okay? Or what actually you are getting? Then basically you need to mention the extraction technique.
Okay. Okay.
Then why we use titanium? What are the main application? You know, properties of titanium. तो आप उसको उस direction में highlight करना चाहिए था. As compared to ferrous materials, titanium density is much lesser and its strength is higher. So they are actually lightweighted, very much lightweighted. So we can use them in aerospace application. Aircraft हम use करते हैं because they are having very high strength, very good toughness, very good stiffness. They are having very good corrosion resistance, but they are having very less density as compared to the ferrous materials. So in all those places where we require high strength, high toughness, but lesser weight, we can go with titanium. But it's a costly material. तो उस तरह की एप्लीकेशन में हम इसको यूज कर सकते हैं. अब मेन competitor India में, like if you will compare international market, what are the main titanium producing countries? Which one is at the top? You need to have some basic information about that. India उसमें किस पे आता है? और इंडिया में how much is the percentage share of this Travancore Titanium Limited? Travancore का कितना percentage share है? And what are the other main competitors? Okay, so basic information, these kind of things you need to explore. Material, extraction, properties, competitors, production. Okay.
Okay.
उसके बाद some basic things related to material science like heat treatment process. Although you answered that quenching process, quenching में क्या करते हैं when we are carrying out sudden cooling, तो जो आपका grains है, grain will not be able to grow. We will have a fine grain structure. अब जब एनालिसिस करते हैं तो ग्रेन ग्रोथ होता है. ओके, जब ग्रेन ग्रोथ होगा तो आपको क्या मिलेगा? यू आर गोइंग टू गेट द डक्टिलिटी. डक्टिलिटी इज गोइंग टू इंक्रीज. तो वेल्डिंग में जब हम कर रहे हैं, सपोज यू आर कैरिंग आउट द वेल्डिंग एंड यू आर अलोइंग इट टू कूल इट एट ए स्लो रेट, तो आपका जो जॉइंट है वो बहुत वीक हो जाता है. So we carry out welding at the same time we carry out some kind of quenching also so that it will be able to retain some sufficient hardness. तो वो ठीक है, but heat treatment processes are more important. They can ask you some question from that. अब टाइटेनियम का melting point, other properties, I think there are very less chances they will ask you the phase change diagram, but वो पूछ सकते हैं अगर टाइटेनियम निकल का जो फेज डायग्राम है वो आपसे पूछ सकते हैं, बट बहुत कम चांसेस है. अगर टाइम नहीं है बिकॉज टुमारो यू आर हैविंग योर इंटरव्यू, सो आई थिंक यू कैन लीव दैट टॉपिक. वो कोई जरूरी नहीं है. कुछ डोमिनेंट फेजेस होते हैं इसके, डोमिनेंट एलोट्रोपिक फेजेस, जैसे टाइटेनियम के अल्फा बीटा. तो अल्फा बीटा टाइटेनियम, तो वो थोड़ा सा वहां से आप देखना कि व्हाट इज द डिफरेंस बिटवीन हाउ व्हाट आर द डिफरेंट ग्रेड्स ऑफ टाइटेनियम अवेलेबल. टाइटेनियम के ग्रेड कौन कौन से होते हैं, और ये जो अल्फा बीटा मैंने दो एलोट्रोपिक डोमिनेंट फेजेस बताए, इसमें क्या डिफरेंस है.
Okay.
ठीक है, अल्फा टाइटेनियम और बीटा टाइटेनियम में क्या डिफरेंस होता है? These are the main two allotropic phases of titanium.
Okay.
बाकी मटेरियल साइंस का बेसिक नॉलेज और द सब्जेक्ट व्हिच यू आर मेंशनिंग एज योर फेवरेट वन. तो आई थिंक यू प्रिपेयर टू ओनली. प्रोडक्शन आपने बोल दिया बट प्रोडक्शन आपका प्रिपेयर नहीं था ना, आपने प्रिपेयर थर्मो और सोम किया है.
Yes, yes.
So if you are mentioning production, suppose in that case if you are mentioning production and if we are asking you one more subject, तो थोड़ा सा प्रिपेयर करके जाना रोलिंग वगैरह का.
Okay, okay.
फोर्जिंग जो प्रोसेस है, यू कैन मेंशन कि सर आई लाइक प्रोडक्शन बट दिस टाइम सर आई प्रिपेयर्ड दैट पार्ट ओनली फोर्जिंग. एक पार्ट देख के जाओ एंड मेंशन दैट ओनली. एंटायर प्रोडक्शन करोगे तो थोड़ा सा दिक्कत हो जाएगी. ठीक है.
Yes, sir.
रिमेनिंग योर डिलीवरी इज लुकिंग फाइन एंड मोस्ट ऑफ द क्वेश्चंस यू आंसर्ड ऑन द राइट लाइन. So from my side it's okay. I have not found any kind of problem, but yes, some more kind of work is required at your end. If you will explore these kind of things, I think in a better manner you will be able to present yourself. Okay.
Okay, okay.
Okay, Don. Best of luck. Good luck for your interview.
Okay, thank you, sir.